We have seen two of the most important concepts of Java already, classes and instances, also called objects. We're going to have a closer look at the class members now and how to use these on instances. Roughly speaking, there are two types of class members. Some of them describe the specific instance and some of them belong to the class. Let's have a look at the first group first, the class members that are part of the instance. Classes can contain certain fields and methods that become part of the instance. That might sound a bit fake, so let's go back to our house example once more. The blueprint of the house could have several different properties. Just some random examples: price, color of the front door, whether or not it has an extension, who the owner is, what the address is, etc. Every single house has a field for this property, and this property could have a value. It's also possible that the property doesn't have a custom value. In that case, it will have a default value. So let's have a look at our houses. They will have fields for these values. You can see that the first house, the second house, and the third house have different values. The last house doesn't have an owner yet. The value is null. Let's examine the properties on our account class in IntelliJ. As you can see, our account has an owner, a balance, and a minimum balance. We define these on line 4, 5, and 6. This means that every instance of account can have a different value for owner, a different value for balance, and a different minimum balance. Not only can classes have properties, they can also have methods. Again, let's start with our house example. Methods are things that can be done on the house. We have special methods that give access to the properties and allow us to get them and update them. These are called getters and setters. But we can also do different things on the house. For example, estimate the value of the house. This method belongs to the instance, meaning that the estimate value house is going to be different for every instance of the house. Clearly, we need an instance of the house to determine its value, and depending on the properties, the value might actually differ. So, properties are, properties. They define the house, and methods are actions, code snippets with a name that can be executed. In some other languages, these methods are called functions. I might call them functions every now and then as well, but Java calls them methods. Let's see an example of a method on our account class. So right now we have two methods already. We have a method deposit and we have a method withdraw. The method deposit is defined on line 8 till 10. The details are not too important for now, but what is very important is that you can recognize method calls by the parentheses, and the method definitions have both parentheses and then curly brackets. Between the parentheses, we can define an input for the method. Again, we'll dive into these details later, but just to give you a clue for now so that you have an idea of what you're looking at. We can also create getters and setters. Usually, the properties are private, meaning that only the class itself can access them directly. Therefore, we would need getters and setters to access them from the outside. So let me generate the getters and setters and then let's have a quick look at them. So for example, let's have a look at the first one on line 16. This is a method to get the owner of the current instance. And line 20 is a way of setting the owner, updating the owner with a new value. As you can see, this method requires an input. And after that, you can see that exactly the same is happening for both balance and for minimum balance. But we could also create other custom methods. For example, we could go ahead and create a method called calculate creditworthiness. So I'm going to say public. And then let's just say that this is going to return a certain number. Calculate creditworthiness. I'm not sure how this one will work, so let's say that we omit the implementation for now. But we do need to return a number, so let's return 100. Clearly, this is not a real implementation. This is just a demonstration of what a method in a class looks like. As I've already mentioned, classes can also have constructors. We have used these already when we created a new account in a previous video. Constructors are used to create a class. So far, we have only used the default constructor. We did this when we used a new keyword. We are definitely going to examine constructors in more detail and learn how to create custom constructors, but that's not for now. You're not ready yet. We need to cover some other concepts first to be able to understand these details about constructors. So, what about the other group of members on the class? The ones that belong to the class and not to the instance. These are the so-called static members. They are the same for all the instances of the class, and we will see these later in more detail. But let's briefly touch upon them here already. Static members exist independently of the instances, so they already exist after defining the class before having created an instance with a new keyword. Let's explore what they are with our house example again. The house has an architect, and the architect has created the blueprint. Even when there is no instance of the house yet, the house will have an architect. Also, when there are multiple instances of the house available, they'll all have the same architect. For now, just know that static members actually live independently of the instances and belong to the class, just like with our architect example. And therefore, we cannot use the instance members in the static methods, because it's possible that there is no instance available since they exist without there being an instance. To be honest, I have not covered everything that could be a class member yet, but I have covered more than enough for your brain to process at this very moment, or should I say, very instant. We're going to explore the concept of packages next.